Yeah, so today we'll be talking about this airflow features. So what exactly airflow is and how it's used in industry, why it's good and why we should use it. So all the features from the scratch from the beginning we are going to see. So basic agenda for this session is we are going to get introduced to airflow. Then we'll see what are the airflow concepts. So basic concepts we'll see. After that, what are the components we'll be majorly using in airflow, both from support perspective and from development perspective. Then we'll go over high level steps of how we can install airflow on Windows, and then some of the trigger rules, what are the operators, what are the XCOMs. So these are all the little depth developer level concepts, but we'll try to cover each of them. Okay, so let's start with airflow. So whenever we learn any new technology or new framework, there are I feel like there are two most important parts which we need to really convince with. These two parts are what and why. Okay, so what we are learning and why we are learning it. Okay, so first I'll cover what. So what is airflow? Airflow is a scheduler. So let's say I have written one script to load a data from source to target. Now my ask is I want to do it on daily basis. Okay, so I don't want to do it manually. So for that, scheduler is used. So what I will do is I will get a scheduler like Airflow, put that script inside that scheduler and define some time. So this time might be a daily timing, daily 10 a.m. or weekly timing or monthly timing, anytime, right? So this is a Airflow scheduler. It's based on Python framework. Okay, so we'll see what is Python framework. It worked on distributed computation system. So we can deploy Airflow on the clusters of systems. So it's not bounded with the vertical scaling. So it's not like if you install on one computer, we can extend it to multiple computer later on if our need is increasing, and it is so much flexible. So it's not like whatever custom functionality you want, as it is a framework, whatever custom functionality or requirement you have, we can directly program it in the Airflow. Okay, so these are the some power points for the Airflow, why we are using it. So first thing is, to do any particular task, we have multiple ways, right? But we have to choose what suits best for our application. Okay, so for scheduling, there are multiple solutions available in the in IT in market. First is cron tabs, which is very popular since very recent. So cron tab is basically a Linux based utility, and which is mostly in found inbuilt in all the Linux based system. So what we have to do is it's totally command line based. So we have to enter some commands and come up with a script where we have to give which script to run, what parameters to pass, and at what timing. Okay, so these are known as cron tabs or cron jobs. But the thing is, cron jobs are very basic, so it will not handle so many stuff. For example, if we want to check the your particular schedule or the schedule script is pass or fail, we have to it's there's no inbuilt functionality for logging. So that's why we have to write again custom logic to pass this informations and metadata to separate file, and then check manually this file if it's successful or not. So it's very basic usage. Again, as per our requirement, we can add the logging part or failure detection part, but again we have to write it from scratch, so it's not very efficient. Then second option is tools. So in market there are lot of tools available which will directly give you a nice software like UI, which you can just click some buttons, add some tasks, and directly you can schedule the job. But again, the thing is, tools are very limited. So let's say if you have opted one tool, and tomorrow, let's say you have one requirement which is not fitting inside that tool. So it's not possible to get that requirement done because tool itself doesn't support it, right? So we get little limitation there while using the tools, unless it comes from the vendor. It's not possible to work on some custom requirements. So Python framework is basically hybrid of these two approaches. So what framework is? We can consider framework as a library of multiple functions. Okay, so there are multiple Python functions already written for you. What you have to do is we have to just create one workflow, like we can consider it as just joining the puzzle, right? So as per your requirement, you can add the functions, add the dependencies, and whatever custom logic. As it is pure programming, you can add multiple loops, you can add if-else statements, and it's very flexible. And also we are not writing from scratch because functions are already there. We just have to call those functions. And also if there is custom requirement, we can create new functions as well. So it gives us advantages of both cron tab, the flexibility of cron tab, and ease of tools as well. That's why Airflow is being much more popular in recent time. So let's see, on high level, it's just a theoretical part. The Airflow architecture basically consists of two nodes. First is master node, and second category is called worker nodes. Okay, so master node on high level, it manages all the metadata. So for example, let's say you have created one workflow. Okay, so what is name of that workflow, what is the schedule time, how many tasks inside that workflow, all this metadata is stored and managed by master node. And the actual script which you are going to schedule, those scripts are run or taken care by this worker nodes. Okay, nodes are nothing but let's say these are independent computers which has separate CPU, separate RAM, separate hard disk. And because that to run any program we need some RAM, some CPU. So these are nothing but the resources, and nodes are nothing but the bundle of these resources, independent bundle. So if you see here, the worker node 1, 2, and 3, these are very independent workers, and you can run 3 processes parallelly. So it's good for performance as well. So this is the sample DAG. I'll tell you what DAG is, but this is basically a workflow, how it look like in Airflow. So DAG stands for Directed Acyclic Graph. So this is a simple graph, and any graph basically consists of 2 elements. First is nodes and second is edges. Okay, so in Airflow terms, nodes are nothing but the tasks. The green sections you are seeing here, these are nothing but tasks. Okay, and the arrows are nothing but dependencies. So it's very easy to understand. If we take a look at this example, we can see that first we are reading data from MySQL. Okay, this is just the name of the task. Inside this task, it could be one script, it could be 2 scripts or multiple scripts, whatever. But on the high level, this task comprises of reading of MySQL data and bringing into Airflow. Okay, again this is parallel task, right? So we are reading parallelly the files as well. After that, if both the tasks are dependent, then only combined task will run, combined data task will run. So that's why there is dependency. If you see these arrows, if both the tasks are successful, then only this combined task will run. After that, once combined data will run, then we are going to delete duplicates. Now this could be another script, right? After that, parallelly we are reading SQL Server data as well. Okay, now if these 2 tasks are completed, then again combined data, one task will get created, and after that we are loading to target database, whatever target database, or we can create a file, push a file, whatever as per your requirement. But this is how a graph look like. Now this is one DAG. Now you can schedule this whole process in the Airflow. Now if I want to run all this process daily, what we can do is we can create a DAG and schedule it at a day level. We can define time as well. We'll come to that. Okay, so this is how sample DAG looks like. This is a workflow. Workflow is managed by workflow engine. That means manage scheduling and running jobs and data pipelines. So these are nothing but responsibilities of the master node, which we have seen earlier. This is just a theoretical part. Basic terminologies. We have seen what is DAG. So combined workflow is known as DAG. Inside DAG, we have multiple tasks. So task is a defined unit of work. Okay, it's a single unit of work. Task instance is an individual run of a single task. Okay, so basically we can consider DAGs and task is a blueprint. Okay, it's just a model. When you actually run the task, the new task instance or DAG instance will get created. Okay, and this is known as task instance. So daily, if we are running the task, so daily new task instance will get created. Okay, it's easier for logging. If you want to check what happened in the yesterday's task or its run, you can go back in time and you can check those logs. Okay, DAG is nothing but directed acyclic graph, a set of tasks which explicit execution order, the dependencies we have seen, right, and beginning and end. So it always starts from left and end to right. DAG run, again the individual execution of DAG is known as DAG run. Dependencies, the arrows which we have seen, each task is dependent on another. Okay, it could be parallel as well, it could be sequential as well. Operators. Now the operators are, we can see while DAG is described how to run a workflow, operators determine what actually gets done by a task. Okay, so each task we have seen serves a specific purpose. Okay, so if you see here back, so first two tasks are reading from MySQL and reading from file. Okay, so to read from MySQL, there should be a connection from Airflow to MySQL server, right? So there are separate operators, each operator. So if you want to connect to MySQL or Postgres or SQLite SQL server. So for every database, they have provided, Airflow has provided inbuilt operators. Okay, let's say MySQL operator or SQL server operator. It's ready-made. You just have to put the credential, the host name, port name, and login credentials like username, password, and you can get connected from Airflow to external systems. Okay, just like database systems, Airflow provides connection to file systems as well. So in the cloud, there are multiple file systems, like we have Google Cloud Storage. In AWS, or we have S3 storage. These are the blob storage, right? File storage. So Airflow provides operators to connect to this file storage as well. So it's very easy to use, and these are known as operators. Okay. So here are some sample operators. First is bash operator, executes the bash command. If you just want to do some, let's say, echo and date. So in Linux, basically in command line, to see a date, what we do, echo date, right? But to execute that bash command through Airflow, we need something called bash operator. So it executes the bash command. Same like Python operator. If you want to execute some Python code, Python operator is already present. So if you see, it's very easy and it's very flexible to use. Every operator is there. If you want to send email to a single person or an organization or multiple groups, email operator is already present. You have to just put addresses to address, CC address, subject, and content body of the email, and Airflow will send emails to target audience. Okay, HTTP operator, send HTTP request. Snowflake operators. So if you want to connect to Snowflake database, Snowflake again is one of the databases. If you want to connect to Snowflake, there is Snowflake operators. So task is basically consist of operators. If you want to create a task, you have to use one or the other operators. So now it's really important to identify what kind of operator you want. If you want to run a Python code, you have to write a Python operator. There are a lot many Python, operators are available in Airflow. You can explore it out. Okay. And after that, these are the sensors. Sensors are nothing but, I would say, these are like file watchers. Okay. So let's say you have connected to MySQL, but your requirement is whenever the new data gets updated in the MySQL particular table, our DAG should run. Okay. Now this is very custom requirement. It is not based on time, or it is not based on anything else. It is dynamic request. If update in MySQL, then trigger the DAG. So for this custom purposes, we have something called sensors. Okay, so there are a lot of sensors available. We have GCS sensor, we have MySQL sensor. So in file system, let's say we have a requirement, any new file comes, then we have to trigger the DAG. It is not scheduled at the particular time, but whenever the file arrives, then the DAG should run. So for that purpose, we have sensors. Okay. Branching operator, again, branching is one of the operator to see if else condition. Okay. If let's say I have one program, and that output of that program either 1 or 0. Okay. If output is 1, then perform task branch A. If output is 0, perform task B. Okay. So it's kind of conditional operator that we can use. And triggers. So we have talked about dependencies, right? So how one task is dependent on each on the next one. But the thing is, my requirement would be there are two tasks. So let's say here, here in this case, what by default what happens is both tasks, read MySQL and read file, should be get successfully executed to execute this combined data task. But my requirement is if MySQL or file, any one task is complete, then also it's okay with me. If I lost one data, let's say file data, if I lost it, then I don't care. I just want to, at least out of these two, I want to run any one of the tasks, then that's fine for me. So for that we have trigger rules which we can set. These trigger rules are basically set on this arrows or this dependencies, saying that either first is 1 1, that means both conditions should be true to execute the next task. Second is 1 0, that means either one of the conditions should be true to create to execute the next task, and likewise. So you can take a read here. These are all success, that means all parents have succeeded. All failed, all parents are in failed, upstream failed state. All done, one failed, one success, none failed. Okay. So these are just like logical conditions. After that, there is something called Airflow UI. So whenever you install or set up a Airflow utility in your cluster, so Airflow provided a very nice user interface where it's very easy to see how many DAGs are there, who is the owner, how many task runs are there, what is the schedule of the DAG, and so on. So I have one sample UI open here. So if you see, these are all the DAG names. Okay. So these are separate workflows. Okay. Inside each DAG, we have multiple tasks and dependencies. Okay. So when you click on this DAG, this window will open. Okay. Who is the owner? So who has uploaded the DAG or who has created the DAG? It indicates by who is the owner. These are the runs. Schedule. If you see, there are two approaches, two ways where we can schedule a DAG. First is cron tab, and second is @daily, @monthly, or these kind of aliases. Okay. When the DAG has, what is the last run of the DAG? When is the next run? When is next time it's scheduled? The recent tasks, and there are multiple links. There are multiple action. We can trigger a DAG manually as well. So there's the option. We can delete the DAG from here, and there are multiple links. So here are multiple options. We can see the code of the actual program from which this graph has been created. These are multiple options: duration, calendar, graph view. These are different views to look at a graph, right? So we'll come to that. DAX depicts complete workflow, consists of task and its dependencies. Stands for directed acyclic graph. This all we have covered. Um, yeah, there's this on the extreme left side. It's indicator if the DAG is active or inactive. Okay, so currently all DAGs are inactive for now. We can click it and we can make it active. So here, if you see, the second DAG is active now. Okay, and the runs are 1. Recent runs are 1. Okay, so that's how you can see it. Now whatever we have seen here is a graph view of the DAG, right? This is the graph view. Now similarly we have something called tree view as well. Okay, so how tree view looks like is like this. Okay, if you see here, DAG tree view, two majorly DAG views are there: tree view, graph view. Shown below is a tree view of a DAG. Okay, so it represents so how many days DAGs has run before today. Okay, so this window shows open DAG name and option to turn this DAG off, on, and toggle. So if you see here, there's this option to on or off DAG. In the second panel, it gives metadata information. Okay. After that, there is a code option from where we can actually see the program. What this DAG consists and what is the actual Python program behind it. Okay. And each vertical line of squares shows a particular DAG run status of each task. Okay. So basically, each vertical line is one DAG run. Now, if you remember, we have differentiated between a DAG and DAG run, tasks and task instance. So these are all the task instances of particular days. So if you see, this is Saturday, 31st August, I guess. This DAG has ran. This should be 1st September, 2nd September, 3rd September, and so on. Okay, so each vertical line is each day's run or day's execution. Okay, each color is specific, mentions the specific state. So if you see here, it could be multiple states. Skewed light green is running, red is failed, that means particular task has failed. Yellow is up for retry. So if the task failed, I guess by default it waits for 15 seconds and it's again up for retry. Okay, so that means yellow. Pink is skipped, gray is kind of scheduled, and white is no status. So basically, as we have seen, there are worker nodes which actually executes this task or script behind this task. If the resources are not available or all the resources are full, then it simply shows no status. That means white, no resources to execute. Okay, so that's the thing. That's the tree view. And graph view we have already seen. So these are multiple tasks. So if you see dark green means executed successfully. Okay, start and td extract s3. So we are extracting data from s3, which is nothing but a file storage on Amazon cloud. So that is completed. Copy load is task. This is red, that means it failed. Now the thing is, if one task is failed, all the downstream tasks dependent on that task will be either no status or skipped. Okay, so a workflow will break there. If once it is failed, a workflow will break there. And end is yellow, it is up for retry. It will always be yellow. If the previous parent tasks are failed, then the all downstream tasks will be yellow or white, no status. Okay. After that, there is something called admin panel. This code view DAG shows all Python code. Yeah, code view. This is the code view basically. If whatever you are seeing in the snapshot, this is a code view. So we'll come to what Python program of particular DAG looks like. So we'll come to that. But this is how basically you see the code. Okay. The admin tab, it's one of the important tab. So in admin tab we have something called variables. Okay, so these are the global variables which is common across all the DAGs. Okay, once you define variable here in the admin panel, it is accessible inside all the DAGs which you have. Okay, so variables are Airflow variables are nothing but global variables, and it's commonly used in DAGs for particular environment. Okay, configuration: the first time you run the Airflow, it will create something called airflow.config in your home directory, which consists of Airflow's configuration. You can edit it, change it. And that's not necessary. Connection. So as we have taken example, right? You want to connect to from Airflow to MySQL database. So it's an external system, external database. Now to connect those database, we need some login credentials or host and port information. So instead of hard coding that information inside your code, DAG code, what is best practice is there is something called connection. If you see in admin panel, there is third option called connections. So what you can do, you can set up a connection there and just call that connection inside your program. So inside program, it's not hard coded, right? So once the connection is created, you can call it in multiple DAGs if the same connection, right? The same connection is required. So that's again very modular and powerful thing. You can create a global objects and you can create in multiple DAGs. Okay. Just like plugins, you have a plugin manager built in that you can add multiple plugins. Pools are nothing but resource group consumed by the DAX execute. Resource groups are nothing but the nodes, worker nodes. We don't have to worry about it. XComs to send the data between the tasks. Okay. So sometimes here, if you see the requirement, again I'll go to back to the first example. Read from MySQL, read from file. Now whatever data we have read, we have to pass it to another task, right? So we are passing data from one task to another task within the DAG. Okay. So for that purpose, we have something called XComs. So there are commonly used two functions: XCOM push and XCOM pull. Okay. So what is XCOM push? Whenever you want to send the data from one task to another task, you have to push it. XCOM push. And in the combined data, you have to pull the data, right, from the previous task. So we will use XCOM pull. Okay. So just remember that XCOM pull and push to pass the data between the tasks. Okay. Airflow 2.2. So it's cloud managed service. We don't require it. Now we'll come to the DAG code. Okay. So how the code of DAG looks like. So basically it's a Python script. It's pure programming script. You can add whatever logic you want, the conditions or the loops, whatever. You have full flexibility of Python. And this code then converts to the graph, which we have seen, Python, the workflow or DAG, which we have seen. So Airflow framework takes your script, Python script, and converts it into a DAG. Now this code, Python code needs to be written in 5 sections. Okay. First section, import all the libraries. We will take an example. Import libraries. Then we have to create some default arguments. Then DAG initialization. Then we have to create tasks inside it, and then we will add the dependency between the tasks, however we want it. Okay. So let's see what the simple DAG looks like. Okay. Yeah. So step 1, importing all the necessary libraries. See, first of all, from Airflow is master library. From that library, we are importing DAG. Okay, DAG is again a function which will create our DAG. Okay, so in this example, I guess we are using datetime. So we are using just datetime library. Yeah. So to create any task, as we have mentioned earlier, each task is one operator. Okay, each task is one operator. Now here we are using a dummy operator. What is dummy operator? It's just a I would say it does nothing. It just simply executes it. Okay, it's a dummy operator. Then step 2, section 2, we have to create default arguments. Now what are the default arguments? It's whatever we are seeing in the Airflow UI, right? So first of all, what we saw, who is the owner? So we have to define owner here. Okay. Now second is depends on previous past. Okay. What does it mean? If we see the tree view, we can see multiple vertical lines. That means multiple instances, right? Now we can add logic such a way that if yesterday's DAG is successfully run, then only execute today's DAG. So such kind of dependency we can add here. Dependent on past. Here we are writing false because we want each execution is independent one. Okay. Now we have to define start date. Start date is usually day before you want to deploy the product DAG. Okay. So if I want to deploy today, I will give yesterday's date. Okay, one day before. And retries. Currently we will keep it as 0 because if it's failed, then it's failed. We don't want to retry it. Now the third section is basically creating a DAG, okay, or initializing a DAG. So there are few arguments which we have to give for creating a DAG. Okay, so what are these arguments? First is DAG ID. DAG ID is nothing but DAG name which will appear in your UI. This UI. Okay, so DAG ID for this is example bash operator, example branch label. These are all the DAG IDs which we need to define here. Default arguments is nothing but whatever we have created, who is the owner, if it's dependent on false here. So all this information we are passing here. Catch up, just ignore the catch up, it's not required. And schedule interval @once. So here we have written daily. Here it's cron tab exception. Here again it's daily, right? So that we need to define here while initializing the DAG. Now this is section 3. In section 4, we have to actually create the tasks inside it. Now as we have imported the dummy operator, we will create a task. We'll create a start task and end task. Okay. So if you see, we have created 2 tasks. Okay, using dummy operator. Now what is the task ID? Start. And DAG equal to DAG means we have to associate this task inside this DAG1. Okay, this is what it represents, and it's compulsory attribute we have to give it. Now this task ID again is whatever we are seeing here. Here if you see, run this first, this is nothing but the task ID. Okay, branching is nothing but a task ID. Okay, this is the start and end task which we have created. And the section 5, last step is define the dependencies. Very easy. This is right shift operator which we have to create. This indicates end task is dependent on the task start task. Okay, if start executed successfully, then only end will execute and run. Okay, so this is how basic structure of the Python code. Now once this Python code we have written, we have to upload this file to DAGs folder. Now we'll show you where the DAG folder is. We have to get the admin accesses for that. Once the folder is there, you'll see DAG of new DAG of name DAG-1 because DAG ID is DAG-1. So you'll see new DAG here called DAG-1, and if you open it, you'll see 2 tasks here, start and end. Okay, so that's how basically you create a task or a DAG. So this is basically a developer side of it. If you want to check the logs, then there are directly options here. If you click on any task, or if you go on details, you can see the logs, what script it ran, how much time it took, what are the steps, or what are the logging information. All information you'll see in the logging section. Okay, and after that Yeah, I think we have covered all this. So these are the basic steps which we need to perform to set up Airflow environment on Windows system. Okay, so it's very easy. We have to upgrade the first environment, then we have to install the package manager, which is Python 3 pip, and then we have to install the Apache Airflow. This is complete Airflow library. Then we have to initialize the DB. So we have to initialize Airflow DB because we want to store all the metadata, right? So that's why init DB, and then we have to just start the server. The command is Airflow server -p 8080. 8080 is a default port, and then we have to execute this command Airflow scheduler. So all the DAGs which you have created, they will be continuously running at the particular interval which you have specified in your code. Okay. So this is basically the complete, basic overview of the Airflow. This includes how we can interact with Airflow through UI, and also the developer kind of view, how to create your own DAG. What are the all the operators you can explore? What all the operators you can use, and how we can add the dependencies, how we can add parallel tasks, and all this information, how to check logs, uh, what the color code means, dark green successfully executed, light green running. So this is on high level Airflow is the complete architecture, the UI and developer side of it. Okay, so I'll try to share some documents and useful links as well. And also there are some Stack Overflow articles about how you can set up this Airflow in your own system. So I'll try to find resources on that and I'll share it with you. So in case if you find or if you want to go deep dive into any particular section according to your profile, for example, if you want to go more into logging, how to check logs and how to get to know which script running behind this task. So I'll again try to connect with you and try to discuss how to check those stuff. And if even if in developer side, if you want to know what more operators are available and what more we can do with the Airflow, we can connect on that as well. Okay, so thanks for attending this session, and if you need any more information, please feel free to reach out.